with Jim Manico. He works with White Hat. And he's not going to talk about the regular OWASP top 10, which is a top 10 of all things that can go wrong. And Jim, on the other hand, is going to cover the OWASP top 10 things developers should really think about doing, and which will probably, hopefully, make sure we don't have the normal OWASP top 10 vulnerabilities. Jim, are you up for it?
I'm ready to go. Can you hear me okay?
Oh, you have to push this.
All right. Can you hear me?
Do it again.
There we go. Can everybody hear me? There we go. Ready to go. Hello, everybody. How you doing today? Aloha. Aloha. My name is Jim Manico. I'm one of your global board members, just an OWASP volunteer like many of you out there. I'm also the VP of Security Architecture for White Hat. I'm here to talk about a new top 10 from OWASP that I'm working on, the OWASP top 10 proactive controls. You know, I have some respectful concerns about the current top 10. It's easy to complain about things. We are very fond of that in the OWASP community on our email list. We are some of the very often drama queens complaining. That's okay. So I don't want to just complain. I want to do something about it. So today, I'm going to hit send at the end of this presentation and do the initial release for the OWASP top 10 proactive controls up on stage. I'm working on this with Andrew Vanderstock right now. But before we release it, I want to make sure the community looks at it, the community votes on it. It's only branded as an OWASP project, no vendor logos or vendor affiliation. It's done by a large group of people, so we get some form of consensus. There's public voting, and it's for developers, by developers, to assist people in building secure software. I mean, no disrespect. Who here is a pen tester primarily? Who likes to hack web apps? You guys got it easy, shooting fish in a barrel. It's easy to hack web apps. They're wide open. I remember one pen tester I used to work with who's hacking a web app. Oh, I got SQL injection. He's talking to me while hacking it, barely even paying attention, and destroying this top 100 Alexis web app. You guys got it easy. I wish I was a pen tester. I'm a developer, though. I got to deal with you crazy pen testers hacking my apps. And it's really hard to be a defender. It's painfully hard to be a defender. You hackers, you find one thing wrong, I lose. I have to get everything right to have a secure app. So I want to help developers do that. And current OWASP top 10, that's risk-based, that's more attack-based. I'm going to present to you my initial vision for the OWASP top 10 proactive controls for developers. Now, folks, I made the mistake of using Prezi here. This is also a very high-level talk. It's not going to dive deep. Those of you who already are deep into secure coding, this is going to be a very light talk for you. So you may want to go see Satya's talk on Android and SSL, or you may want to go see Roberto's talk on web proxies. And if you need to go, that's okay. You're free to go. So if you want to stay, it's kind of high level, but bear with me. So let's do some Prezi here. Again, my name is Aloha, Jim Manico, and Manicode on Twitter, but let's get to it. So OWASP proactive control number 1, requirements. Step 1. Who here writes code for a living? Anyone? Have you ever seen, those of you who have seen requirements that give you prescriptive guidance to build security into your app, have you ever seen that in a requirement doc? Raise your hand if you have. Anyone? So I got 0 in the room, and that's a problem. I think we can break security requirements up into a couple categories. Number 1, we have core requirements that we can add to any project. These are technical requirements that we can add to a project regardless of the business domain. Query parameterization, input validation, certain kind of password storage. So there's a variety of technical requirements that we should tell developers up front. When we tell them to write code a certain way up front, what do developers do when you get requirements? What do? You do what the requirements say. That's my job. So when I get a requirements doc, I actually read it and try to do what it says. And if there's some confusion, I'll go ask questions to the project manager. That's what the whole purpose of it is, to communicate what you want me to build. I'm not going to go off and build dancing bears for fun. I'm getting paid to build what you tell me to build. No big deal. So if there's at least 10 to 20 requirements we can add to any web project and automatically attack like half of the security requirements we'll see in a web application, and yet we never do it. I think we should start there. It's easy to do, it's inexpensive to do, and it at least starts the conversation around secure development early on. When you start thinking about secure development early on, you get it almost for free. When you start thinking about secure development after you've gone live, what are you? You're screwed and you're hacked. So we need to think about this early. Most of you know about this already. This is stuff that I think we in this community know of already. There's another kind of requirements that are much more difficult to codify early on. This is more business logic security requirements. Talking about access control rules. We're talking about e-commerce custom workflows. We're talking about like banking transactional workflows. Much more difficult to codify, but if we want security, we're going to have to find a way to do it. This is another form of requirements we should see early on within a web application. So that's number one, security requirements. Because even if you don't design secure software, which I think we should, I'll talk about that in just a moment, even if you skip the design phase, if all you do, if you're lightweight, if you're agile, if you are a small business without a lot of resources, if you just come up, grab the cheat sheet series and come up with 10 to 15 requirements out of that series, if that's all you do, it's a giant win in terms of starting the conversation around security before you write code. So next, let's talk about secure design. This is a bit more difficult of a topic than requirements because we really have to get into complex issues that are technical. So I kind of think of this in reverse. Usually people want to design first and then set requirements. I actually want to start with technical security requirements, then talk about design, then talking about business domain security requirements. That tends to be my preferred workflow. When I think of secure design, the first thing that comes up is, how do you do state in an application? There's three main ways to do state in a web application. Number one, you can pass it as a hidden variable in a request or other places in the request in some way. That's state within one request response pair. You can also put state in a session. You can also put state in the database. For example, suppose you want to do account lockout. Where do you track the current logged out, the current attempts to log in as that user? Do you put that current login attempt in the request? Do you put that current login attempt in the session? Or do you put that current login attempt in the database? What do you think? Shout it out. I heard a few sessions. I heard a few databases. No requests, because that's obviously wrong. So I've seen it in the session, but I can just drop the cookie and have a new session every request. So database is where it goes. So that might be an easy thing for us as security guys to come up with. But as a developer who's just trying to get stuff done, I can put it in the request and it will work. I can put it in the session and it will pretty much work. I can put it in the database and it works. But unless we're thinking about the security ramifications, we're going to make the wrong choice. So I want to think about, and these are very difficult conversations to have. It's real nitty-gritty. I very rarely see these conversations, even in some of the best secure coding classes out there. But having these conversations with stakeholders and technical architects and setting standards around that is incredibly helpful to build secure software down the road. So, and then we have business-specific features. This is very similar to the conversation we have in security requirements. We want to design the workflow. We want to think through interaction between software, the business, and security. Things like if we have to lock an account, what's going to be our unlock feature? Locking an account's easy, unlocking it's really difficult. Maybe we have to work with customer service. Maybe we won't do account lockout when a user has multi-factor authentication in place. Multi-factor addresses brute force very well. So very similar to business requirements, there's a whole business domain part of an application that we can't just add to requirements in a templated way or in a way from a generic list. We have to really have the stakeholders discuss what we're trying to accomplish here. And as a side note, when you have the security guy in the room, very often I've been in a security design conversation where the security guy says, no, 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 you can't do this. That's an amateur security professional, in my opinion. The real thing to say as a security professional is not no, but, okay, you want to do something that's insane, risky, and crazy. Let me help you do that in a more risk-managed way. So that's the best security professional, the one who doesn't say no, but the one who says, here's how. So that's the kind of thing I like to see in this part of the conversation. So next, let's talk about secure libraries. Third control, leverage secure coding libraries. If you're going to go out and build your own crypto on your own, you're pretty much going to be at the state of plain text. Getting crypto right is incredibly difficult. And so I want to leverage a library that does it right to some degree. And that's difficult in the world of Java. We have Apache Shiro, which I'm very fond of, the crypto. We have Asapi's crypto, which just found out a couple hours ago. Oh, this is like, Kevin Wall wrote the crypto for Asapi, incredibly well done, incredibly well thought out. We had the US NSA review it and they said it's great. And just yesterday we had a very major hole in that discovered. So that's unfortunate, but that aside, using other tools like JCrypt and other crypto libraries, or at least having experts within your own team build a crypto library that's reused by the rest of the team, this is fundamental. It's very rare where a team is building authentication from scratch on their own. They're usually leveraging some sort of centralized authentication server or centralized single sign-on server, which even though single sign-on tends to be an anti-pattern, it tends to be more secure than having individual developers code it on their own. So we want to leverage some kind of centralized library to provide us with these controls. Some of my favorite ones that I use in production for Java, I'm a big fan of Apache Shiro. It's gone through the Apache process. It's actively maintained by Les Hazelwood. It is rigorous in terms of its quality, and it's one of the flagship projects of Apache, and it's heavily maintained on a nearly daily basis. Big fan of what's come out of Apache Shiro. The other two OWASP projects I use, I'm a big fan of. I'm managers of these. These are small, single-purpose libraries. As much as I like the idea of a monolithic security library, it's very difficult for a developer to use that effectively quickly. So if a developer wants to stop cross-site scripting in Java, I recommend the OWASP Java Encoder project. We wrote it over the last year. It's being used production quality in a lot of different environments. It's high performance, low memory utilization, and has more coding individual APIs than any encoder I've seen on the planet. I'm also a big fan. This is written by Jeff Ikonowski, PhD compiler theory student, one single dedicated developer to build one single purpose control library. This really has a big impact in terms of usability, performance, and production quality. The other library I'm a big fan of was written by Michael Samuel from Google. Michael Samuel wrote an HTML sanitizer that they actually use at Google. This is incredibly high performance programmatic HTML sanitizer to handle untrusted input from libraries like TinyMCE and CKEditor that allow you to do rich text in the web page, but they submit HTML. Anybody want to write me a regular expression to validate a chunk of HTML? No, you don't. It's not going to happen. And so we can't just encode it. We'll just see the code on page. We need a formal HTML sanitizer. And Michael looked at how we were doing at OWASP and said, you really got it wrong. So let me write it for you. He donated it to us from the Kaha project. It is low memory utilization, programmatic a configuration policy, very fast, high performance, Java 1.5 and above. He wrote his own parser from scratch. I'm looking at the code and I call Mike and I'm like, Mike, you actually wrote your own parser from scratch to save you a little bit of performance. He's like, well, that's right, Jim. I'm like, you're nuts. You didn't leverage any third-party library. What do you have, like a PhD in crypto and coding or something? He's like, I have both of those PhDs, actually. Okay, Mike, all right, okay. So it's one dedicated, incredibly deep developer building a really critical control. I'm a big fan of that kind of open source project when it comes to dedicated secure coding libraries. I digress, charging on. Next, identity and authentication. So 4, identity and authentication. Look at, some of these controls are general. This is now, this is an incredibly high level idea. Later on in this presentation, I'll recommend a few very low level controls. So I'm kind of splitting hairs here. Some of these are process based. Some of these are high-level ideas. Some of these are low-level programming techniques. I think this is what we need to influence developers to write secure code, though. So when we talk about identity and authentication, there's some high-level ideas like federation, single sign-on, OAuth type implementation. There's also lots of low-level ideas like, how do I do password storage? Session rotation at login time. You know, we want to use encryption in transit for all sensitive data. It's a big part of initial login. Session management. How do you deal with session management in a cluster? With all the problems with TLS, TLS is painfully broken. And right now we're recommending that you no longer use RC4, which leaves you vulnerable to Beast in most clients, especially Apple clients. So there's really no good way to do TLS today. That will change in months, maybe years, unfortunately. So one of the session management recommendations I have is you should be rotating your session keys per request these days. Very few to no applications or application frameworks do this. But if we tell a developer about it early on, there are ways to implement it in code itself. And we really need to do that these days if we look at the problems we have with TLS. So this section will address some of those. And I struggle with this. Do I break it up into 2 different items? I could break it up into 50 different items. And just to take a step back, if you're building your whole security program on a top 10 list like this, you're screwed. So this is not meant to be complete. In fact, this is a bad idea to do an OWASP top 10 list. It's a bad idea. But it's meant to breed initial awareness. It's meant to start the conversation in a defense-centric way. And I struggle with this one. I'm not sure what the best way to do it is, but it's an area that we need to address. Hopefully we'll come up with like 4 or 5 sub-items, like password storage and similar items to at least get the ball rolling in the right direction. And we have multi-factor, password storage, session management, the forgot password workflow. These are some of the items we'll include in this top 10 item. So what's next? Access control, wonderful. I'm a huge fan of access control design. This is a really fun topic for me. I really think that most of us today are doing RBAC, right? It's pirate-based access control. I'm sorry, it's a role-based access control. Most every web framework, most every application framework is role-based access control centric. And even in the Java world, our 2 big frameworks, Struts and Spring, it's for the most part role-based access control. And guess what? Role-based access control only addresses vertical access control problems. It doesn't address horizontal access control problems. So especially in the modern era of multi-tenant applications, multi-domain applications, multi-tenant applications, we deeply need something more than role-based access control, unless you want to do a lot of manual coding of access control rules all throughout our application, which is an anti-pattern. So I really recommend capabilities-based access control for most web apps I look at today. And no framework that I know of does that, except for one. In the Java world, Apache Shiro. This is one of the reasons Apache Shiro was written, because it's capabilities-based access control centric from the ground up. We're no longer asking the question, are you an administrator? Are you a manager? Are you a user? That's asking a characteristic of the user. I don't care about that. Capabilities-based access control asks the question, should you be allowed to edit car number 37? It's asking about the action that the user is doing specific to a piece of data. Never ask the question who this user is. And when you code in a capability-centric way, you can now push a lot of these rules into a filter. You don't have to litter your code with checks. In a traditional RBAC system, you're doing role checking hard-coded in each individual page or action. And then you get audited for access control. Hey, Seba, you're doing RBAC. So what's your access control policy? And Seba's answer is, well, here, Jim, you auditor, here's 3 million lines of code. It's just in the code. Just go read the code. Fail. So not only is it hard to verify RBAC, it's also hard to maintain, it's fragile, requires manual coding. We need something better, and I really want to push developers in the direction of capabilities-based access control, a little more work up front for a lot more maintainability down the road. This is what we'll be talking about in this item right here. Moving on. Yeah, so limitations of role-based access control, we need a better way, especially in the modern era of multi-tenant programming, which is more common than not in greenfield web projects. So far, so good? Are you with me? Charge. What's next? Yeah, capabilities-based access control. Woohoo! It's data-centric access control. And Another interesting aspect to access control, detecting server-side access control violations is poor man's intrusion detection. When you have a well-written application, you should only present users with forms and features that they have access to, right? So when you start seeing access control failure server-side, it's an easy thing to track that will specify you're under attack. Other things that I like to, as a side note, other things I like to trap in code is when I have a checkbox. So when you have a checkbox in a web form, what should you get in, what are the possible choices you can get in the request from a web form checkbox a user may check or not? What are the possible choices you can see in the request? Checked or not checked, true or blank. There's like 2 choices you will see, and that's it. What if you get something other than that value? What happened? Suppose you have a checkbox, you allow true or empty. True if it's checked, and empty string if it's not. What if all of a sudden you see script, alert, blah, blah, blah? What must have happened? Someone's using Zap or Burp or some proxy or tampered data, and they're interfering with your request. And in my code, I like to know the moment someone tampers with my request. So when I'm looking at access control violations or modification of immutable user interface widgets, I know right away some little pen tester like half of you in this room are messing with my code. And I'll go honeypot you or lock your account or at least let the smarter guys in operations deal with it. I can take action early on. When do most companies know that you've been hacking their web app? When you put their passwords on Pastebin or something like that, right? So, I digress. Charge. Next, yeah, and so here's an example of a OWASP top 10 control that I think should be its own category, query parameterization. So we've gone process, we've gone big with authentication, we start to narrow down a bit with capabilities-based access control, and now we're getting really granular, query parameterization. Why do you think I'm making this I'm suggesting that we should make this an entirely separate OWASP top 10 item? Why do you think? When I talk about query parameterization, what risk am I talking about? How bad is SQL injection even today? So pen testers, when you see SQL injection in your test, what does that mean? Once you found the most brief, the smallest of SQL injection vulnerabilities, what are you able to do to that application? Steal all data, modify any data, and sometimes even do command injection through SQL injection. This is an epidemic, and I'm primarily an educator in my job. The first thing I ask most rooms is, how do you stop SQL injection? And to this day, I get in front of even some very senior smart developers, and they go, input validation, data sanitization, just use stored procedures. Wrong, wrong, wrong. I hear it all the time. Query parameterization is the #1 way to stop SQL injection. It's an easy technique. I think it merits its own top 10 control because it's such an epidemic. Let's parameterize those queries, folks. And it's an easy one for developers to win at. So validation, input validation. You know, I usually badmouth input validation. A lot of security books, security courses, very smart people have said the core of application security defense is input validation. And Jeremy Long, I agree with this 100%. Jeremy Long and I were talking at the last OWASP conference, and he told me, Jim, I can build the ultimate, perfect, most secure web application on the planet and completely skip input validation. And he's right. Now, input validation is still important. It's good hygiene in your code, and especially when you're validating integers or like usernames that just accept lowercase letters, you actually do get really good security in that input validation layer. But then developers think that that's all they need. It's like a drug. They think that I can just do input validation. It's usually pretty easy to do in most web frameworks, and they think that's security. Then all of a sudden, they're building a news article or some kind of media article, and they have comments underneath it. And what goes in a comment? Full sentences, uppercase letters, lowercase letters, spaces, punctuation marks. Hackers, once I give you letters, spaces, numbers, and punctuation marks, what else do you need to cause damage? You need anything else? Usually not. So especially when we're dealing with open text, which is very common in social media, very common in collaborative features, validation becomes almost useless. Not to mention trying to build an internationalized application. You have to really support multiple countries. Good luck doing regular expressions on complex data supporting multiple languages. Very often developers punt, and they do this with a regular expression, with the big P, printable characters only. So hackers, if I give you printable characters only, what can you do? Absolutely anything you want to. So I think input validation is important. It is a critical control. We have to do it. It's good hygiene. It protects us with certain data types, but it's not the end-all be-all to security. And to this day, like 3 of the top 4 secure coding books sell input validation as the answer to all of your security problems. And believe me, it's not. So my much more important control when it comes to injection is encoding. Encoding is the basic technique of converting input from a potentially code context into a data-only context. And this is the heart of what we need to stop cross-site scripting, of course. This is one of the top 3 controls needed in the family of XSS defense. We need output encoding in about 10 different contexts for a really complex web application. We also need HTML validation. We need to avoid certain APIs in JavaScript at the very least. So, and to this day, most programming languages do not include an encoder. And I know we all like to bash Microsoft about 10 years ago. The only web framework I know of that has a reasonable encoder built in from the ground up is .NET. They've had it for several years. It's not getting a lot of love these days, but it's still there. It's still at least remotely useful. And there are a lot of other mechanisms to stop cross-site scripting. There's WAF-type input validation. There's just normal framework-level input validation. But again, when we hit these open text fields, open comments, collaborative features, that validation breaks down. And the blacklist validation, I'm a big fan of some of the work we see Ashar doing. He's one of the top XSS bug bounty guys in the world. He released a white paper that describes input validation, regexes, blacklist validation to stop XSS. It's still debatable, but I know the surefire way to really stop XSS, most classes of XSS, is output encoding in about 10 different contexts, something I think we need to educate developers about to achieve even partially secure code. Woohoo. Let's charge on. And as a quick aside, I've seen a lot of books or articles that say query parameters. It's a quick step back. I see a lot of articles that say all that query parameterization is, this is a way to build a query in an injection-safe way. They say it's encoding underneath the hood. This is not true. I actually recently was decompiling one of the Oracle JDBC to see how they did query parameterization. Milton, don't tell anyone that. Forgive me, Milton, for that decompiling. We have Milton, the head of Java security right here. Hello, Milton. So the way query parameterization really works, the reason why it's such a rigorous defense, it actually sends 2 passes to the database. Pass 1, your parameterized query without the user input is sent to the database. The database sees that query structure and builds a query plan for data retrieval or data updating. And then once that query plan is built, pass 2, the user inputs are sent in. The plan's already built. The traversal tree is already built. Regardless of what input comes from the user, that plan cannot be changed. It's basically pre-compiling queries. It has nothing to do with encoding. So I digress. Next, we have data protection. This is an incredibly difficult topic that I don't claim to be a cryptographer. I've been doing my best to study this in the last year, and it's an incredibly difficult topic that very few people got right. Like I mentioned earlier, encryption in transit is, let's do encryption at rest first. Encryption at rest, to use AES, is brutally complex. Anybody have suggestions for me as to how I can use AES? Just use AES CBC mode and I'm all good, right? It's way more difficult than that. Milton, cover your ears. I don't mean to, just cover your ears, trust me. So let's look at Java, my main language. And this is not Java's problem. Every language has similar problems. When you use Java by itself and call AES, what mode is default for encryption of AES in Java? EBC mode, which is basically plain text. So you have to use AES in CBC mode. Okay, that requires an initialization vector. That initialization vector needs to be unique for every single message. Don't forget your padding. And now that kind of, and make sure you have a really strong key that you keep in secret. And now you have confidentiality, reasonable encryption when you have a unique IV per every message built from a random entropy source, which is hard to do in Java. You need a new instance of secure random on a good OS. So that just gives you confidentiality. Then you want to take the master key, label it as a integrity key, and HMAC the ciphertext with the branch off the master key to give you an integrity hash. And there's no system that does this automatically. To really get encryption right, developers need to have pretty intense knowledge of how to implement AES in their individual language, and almost every language gets this wrong by default. So most implementations of crypto storage that I've looked at, even if they get key management right, they often get the actual low-level encryption very, very wrong. So this is a very difficult topic, and we're going to work with some really deep applied crypto experts to give as much real-world advice as possible in this document. Next, we have encryption in transit with SSL. This is also hugely under fire, right? We have problems with the actual ciphers in use. We have problems with the actual standard, but we also have problems with certificate authorities. We have Moxie Marlinspike's research on you get one bad CA who sells their private cert, and you're man-in-the-middle in real time in trivial fashion with no browser warning. So we have certificate pinning to deal with these less than high integrity CAs out there. We also have the TLS configuration cheat sheet, encouraging devs to move towards more authenticated ciphers in TLS. Really difficult problem. Not to mention the heart of all crypto, good random number generation, random generation, which is pretty much broken in every language by default. We need to do some FM to really pull that off. FM is a technical term. It's magic. Anyways, moving on. And so to finish up, we have logging, error handling, and intrusion detection. This is, who knows the log song from Ren and Stimpy? Anyone? It's log, it's fun, it's heavy, it's wood, right? It's log, it's better than bad, it's good. Anyone? Anyone? No, okay. All right, so go watch some Ren and Stimpy and get back to me. Logging is one of the most boring topics in information security. It's critical if you want any kind of accountability, if you want to be able to do, you're gonna get hacked. The best coders on the planet get hacked. You're going to get hacked. We need logging, of course, to be able to do our forensics after the fact. I really want to spend most of my time in this section talking about intrusion detection. I think to productize or firewall intrusion detection is actually very difficult to do well, but to add intrusion detection inside your code with techniques like using app sensor, detecting modification of immutable components, access control violation, it's very easy to do that. And the visibility you get into actual hacking activity is tremendous. So I'm going to focus on the intrusion detection part. I don't see enough developers even beginning to do this, but it's so easy. We can at least do a few things with almost no effort to give us great visibility. And how much visibility do most operation teams have into the security of their applications? Little to none. So we got to change that. And so let's do this. So let's push this live right now. All right, there's the inbox. We can do this. Leaders, I'm currently on stage at AppSec EU giving a talk on the OWASP Top 10 Proactive Controls. Wish you were here. The initial alpha version of this document was just pushed live on the OWASP Wiki website. I would love your help, feedback, concerns, and complaints. The OWASP Top 10 Proactive Controls is a document intended to be phrased in a positive manner that describes the top control and control categories that every architect and developer should absolutely 100% include in every project. I want to make sure that the entire OWASP community can not only provide feedback, but can also participate in the project directly on the wiki. The final document, which I intend to release at AppSec USA in November, will be branded only as an OWASP project to maintain strong vendor neutrality. For this work to be effective, I really need your help. All comments, concerns will be addressed. You might completely disagree on my top 10 items I have initially chosen, and that feedback will help drive a better document in some form of public voting process. This initial version is just meant to set the groundwork and get the ball rolling. I can only imagine how busy you are, but I'd be grateful for your help on this community project. Introducing the OWASP Top 10 Proactive Controls, the alpha version, just pushing it live right now. You can see it up on the wiki. You'll see it on the leaders list. I would love your help on this project. I want to inform, there's so many developers out there who still to this day have no idea how to write secure code. I want to get them started thinking about this. We need it for our future. Please help me in this project. And thank you so much for your time today. Cheers, everyone.
Okay, thank you, Jim. Do you have any questions for Jim? Questions? Improvement remarks? Anybody? Okay, well, thanks. Break is now, and we see you again in 20 minutes.
Thank you, everyone.
Thank you.